these are the first 31 numbers of the Fibonacci sequence, or simply all of them up to 1 million. And I've mentioned this sequence many times, but I'm here to tell you guys a little bit more about it in depth and show you what stuff it can offer. So, just as a recap, or something like that, I don't think I've explained how this works. I'll do it now. So, the sequence works like this. So, you start with 0 and 1, and then you add up these two terms to get 1 right here, and then add up this and that to get 2, and then 2 plus 1 is 3. So every single number is basically the sum of the two previous numbers before it. And it begins like this. And you simply add them up and then do it again. Go on forever, and this is how it works. This is what you end up with. And what's kind of cool about this is that you can take all of these numbers and then make a shape out of it. To start, you begin with 2 of these 1s right here, and then put 2 right here, and then 3 below it, and then 5, and then you put 8 up here, and then 13 right here, and then 21 here, and then 34, and then you do 55 up here. And you would imagine 89 to go right here. But we don't have any room to fit that. We'll just put it here just in case. So what you do next is you go from where you started, which would be right here, and then simply curve around like this. This is a very interesting shape that people use, like artists use it. This is called the Fibonacci spiral, or the golden spiral. So if you look at an object that is a spiral shape, then you might see a little bit of this in it. Like, this Nautilus shell is a perfect example. You can see how this kind of resembles the Nautilus shell. And the sunflower right here also has this shape somewhere located in it. You may not notice it at first, but if you look really closely, you can kind of see it. And not only does this appear all over nature, but a lot of artists, such as Leonardo da Vinci, actually used this shape in some of their paintings. Yeah. So this sequence is everywhere. So next time you go out in nature and you see a flower that's a spiral-shaped one, then try and look for this. What else is cool about this Fibonacci sequence is that you can actually take the ratio between consecutive numbers. Like, I'll list the first few. If you take the ratio between these numbers, like, for example, 34 divided by 21, or 21 divided by 13, or 13 divided by 8, like, as you go further in the sequence this way, the numbers, like the ratios, will approach the golden ratio, and that is denoted as the Greek letter phi. And this is something that you find a lot. Yeah, so basically this a rational number is basically representing this whole sequence, and you can find it in nature and stuff. And it can be done by taking the ratio between these numbers and approaching it. This golden ratio number is equal to 1 plus the square root of 5 divided by 2. So it's also equal to that, and it equals 1.618033, and it's irrational because it contains the square root of 5 in it. But what else is weird about this is that you can actually square the golden ratio, and you end up with 2.618033. Look at how weird this is. This is literally the same thing plus 1. But 1 divided by the golden ratio equals 0.618033, which is basically this minus 1. So whenever you see the equation x squared equals x plus 1, x equals the golden ratio. Another weird place you can find this number is by taking the fraction 1 plus 1 divided by 1 plus 1 divided by 1 plus 1 divided by 1, and so on. If you continue this fraction forever, it approaches the golden ratio. So this infinite fraction equals this. So this is quite literally the hardest number to approximate with fractions. Or basically equal it with fractions. Like, it is possible. You just do this. So, is it rational? Well, that is one thing about it. And that's it I have to say for this, these weird appearances of the Fibonacci sequence and the golden ratio in certain fields of math and nature as well. See you guys later.